Now it's fine. Let's the problems together. Let's write the name. Your name, okay. Let's see from student's point of view. So let's write your name here. Okay. Now it is fine, yes? Hello?
Yes, fine.
Okay. So the first question says that the units of Planck's constant H is, or we can say, okay, is one of, which one of the following? A, energy, power, momentum, or angular momentum? Check it on your notebook and which one is the correct answer.
Will be kilogram meter square per second.
So which one is correct from this option? Energy cannot be, yes. Power is again cannot be. Compare with the units of momentum and angular momentum.
Momentum is kilogram meter per second.
Therefore, what is angular momentum?
Kilogram meter square per second.
So the unit of Planck's constant is the same as the units of angular momentum, yes? Therefore, option D is the correct answer. Let's see the next question. Question number 2. Which of the following electromagnetic radiations has photons with greatest momentum?
X-ray.
X-ray. Good. So why? What is the momentum of electromagnetic radiation?
Mass per no, X over the wavelength.
Yeah, H over the wavelength. So because in the denominator is the wavelength, the number should be small number to be maximum momentum. So X-ray has less wavelength compared to the other electromagnetic radiation in the option. Therefore, the correct answer is X-ray, because X-ray has lowest wavelength and highest frequency from the other option. Therefore, the correct answer is option C. So what about question number 3? In a photoelectric effect experiment, the stopping potential is A, the kinetic energy of the most energetic electron ejected, B, the potential energy of the most energetic electron ejected, C, the photon energy, D, the electric potential that causes the electron current to vanish. Which one is the correct answer?
B.
The potential energy of most energetic electron injected. Is that the potential energy?
The stopping potential.
Yeah. Did you remember the graph? Current versus the intensity of ultraviolet radiation from your textbook. You can check.
Yes.
Have you got the plot? So from that plot, what that mean the stopping potential?
Magnetic energy.
Okay. So the stopping potential times the electron gives the kinetic energy required to eject the electron, and the energy for the electron, the ejected electron, is proportional to the frequency. So for that case, the current is along the y-axis, yes, from your plot, from your textbook. So for the stopping potential, or the plot goes to 0, in that case, the current is 0, yes, for the stopping potential. Have you got it?
Yeah.
So option D is the correct answer. The electric potential that causes the electron current to vanish is the stopping potential. Is the correct answer. Is it clear?
It's the potential that stops the electron.
The electron current to vanish is called the stopping potential. Good. Let's see question number 4. In a photoelectric effect experiment, no electrons are ejected if the frequency of the incident light is less than the quantity A over Planck's constant H, where H is a Planck's constant. And what is the quantity A in this case? From the option A, the maximum energy needed to eject the least energetic electron. B, the minimum energy needed to eject the least energetic electron. C, the maximum energy needed to eject the most energetic electron. D, the minimum energy needed to eject the most energetic electron. Which one is the correct answer?
B.
B or D?
The least energetic means, yeah, which one?
The least energetic electron.
Yes.
The minimum
What does
energy.
it mean? What does it mean?
The least energetic electron. Electron, the least energetic electron means the electron having least energy. So what does mean having least energy? For example, have you seen from Bohr model, the energy with principal number N1 is minus 13.6 electron volt, yes? That is the least energy. So it is closer to the nucleus, yes?
Yes.
So find the most energetic electron. For example, with principal number 2, the electron energy for that is minus 4 point something, yes, electron volt.
The valence electron?
Yeah, so which one is the correct answer from this option?
B.
Option D is the correct answer, yes? Option D. Why your speaker is mute? So the correct answer is option D, yes? Did you understand it? Hello?
Hello.
Did you understand it?
Yes.
Good. Let's continue the next question, question number 5. The work function for a certain sample is 2.3 electron volt. Prepare your notebook and pen for this problem. The work function is 2.3 electron volt. The stopping potential for electrons ejected from the sample by 7.0 times 10 to the power of 14 hertz. 10 to the power of 14 hertz electromagnetic radiation is A0, B 0.6 volt, C 2.3 volt, D 2.9 volt.
Work function is 0.3.
0.3, 2.3.
Yes.
Option C.
No, the work function
Uh,
is 2.3.
yeah, the work function is 2.3 electron volt. And the energy by the photon is given by the Planck's constant times the frequency, yes? HF is 7.0 times 10 to the power of 14 times the Planck's constant. Therefore, from photoelectric effect, the energy of the photon is the same as the work function plus the kinetic energy, where the kinetic energy is the same as the stopping potential times the electron, yes? From that expression, you can calculate for the kinetic energy maximum, and the kinetic energy maximum divided by the charge on the electron gives the stopping potential.
Here the stopping potential is HF. The stopping potential is HF.
Don't hear you.
The stopping potential is HF.
Is what?
HF or KE.
No. Write the formula like this. HF is equal to work function 2.3 electron volt plus the stopping potential times the charge on the electron. Yes? That is the kinetic energy maximum. Then calculate the photoelectron energy, HF, which is 7.0 times 10 to the power of 14 times the Planck's constant 6.63 times 10 to the power of minus 34 joule second. Convert that into electron volt. Multiply 1 electron volt divided by 1.6 times 10 to the power of minus 19 joule. Joule by joule cancel. Then at the end of the day, you will get the energy of the photon in electron volt.
Seven times 10 to the power 14 divided by E.
Use the calculator. Seven times 6.63 divided by the charge on the electron 1.6, you will get 29. Then arrange the exponent in the numerator. You have 10 to the power of 14, and for the Planck's constant minus 34. So minus 34 plus 14, you will get 20, yes? In the denominator, for the charge on the electron, you will have the exponent minus 19. Therefore, 20 minus 20 plus 19, you will get minus 1, yes? So at the end of the day, the energy of the photon is 2.9 electron volt, yes?
Yeah.
Therefore, subtract the work function from that. 2.9 minus 2.3 electron volts is 0.6 electron volt, yes? 0.6 electron volt. Then to get the stopping potential, divide by the charge on the electron by E. Then your answer for the stopping potential is 0.6 volt, yes?
The stopping potential
Is the result, that means the energy of the photon minus the work function, you will get 0.6 electron volt, yes?
Yes.
Then to get the stopping potential, that energy is the same as the kinetic energy maximum, which is the same as the stopping potential times the charge on the electron. Then divide both sides by the charge on the electron, you will get the stopping potential. Finally, the stopping potential is 0.6 volt. So option B is the correct answer. Did you get it?
Yes.
Very good. Now let's see question number 6. Which one of the following is not evidence for the wave nature of matter? A, the photoelectric effect. B, the diffraction pattern obtained when electrons pass through a slit. C, electron tunneling. Maybe you will not know this part. D, the validity of Hensel-Bank uncertainty principle. Which one is not the evidence for wave nature of matter?
So how matter acts like a wave?
Yeah. What was photoelectric effect? Photoelectric effect was the evidence for the electromagnetic radiation to be a matter, yes? Option A cannot be the answer, not be the evidence for the wave nature of matter. It is evidence for the
Matter of wave.
waves acts as. So which one is the answer?
A.
A is the answer. Let's see question number 7. A free electron has a momentum of 5.0 times 10 to the power of minus 24 kilogram meter per second. The wavelength of its wave function is A 1.3 times 10 to the power of minus 8 meter, B 1.3 times 10 to the power of minus 10 meter, C 2.1 times 10 to the power of minus 11 meter, D 2.1 times 10 to the power of minus 13 meter. So the momentum is given, yes?
B.
Yeah, and the Planck's constant is known, which is a constant, 6.63 times 10 the power of minus 34 joule second into significant figure. So which one is the correct answer from this?
B.
B. Very good. Option B is the correct answer. How did you get option B? Therefore, the lambda is the same as?
Wavelength
Wavelength is the same as? I mean, the formula, the de Broglie equation.
over mv. mv.
Lambda is?
The wavelength.
I mean, the wavelength, yeah. Tell me the formula for that.
It will be h over
H over what? P.
momentum.
The momentum. Good. That is the de Broglie equation. And question number 8. Volumes of atomic nuclei are proportional to what?
Atomic number.
Yeah, the atomic number. And the formula for atomic nuclei is given by 1.2 times a the powers of 1 over 3, yes? Or the cube root of the mass number A, yes? So option A is the correct answer. Question number 9. A nucleus with a mass number of 64 has a mean radius about, use the previous formula. The mass number is 64. What is the cube root of 64?
4
4 times 1.2?
will be 4.8.
4.8. The unit for that was femtometer. Femto means 10 to the power of minus 15. Therefore, option A is the correct answer. Very good. Now, let's see question number 10. Two protons are separated by 10 the power, this is the power, 10 the power of minus 16 meter. Two protons are separated by 10 the power of minus 16 meter. The nuclear force is N, the electrostatic force is E, and the gravitational force is G between the proton in the order of increasing strength. Therefore you have to order from least to greatest strength of the force. Which option is correct? A, ENG, BNGE, CGEN, DGNE. Which one is the correct answer? So the least one from the 3 types of force in nature is the gravitational force is the least one, yes? Then the strong nuclear force is the strongest force in nature. Therefore, that is the maximum force from this. And the electrostatic force is between the gravitational force and the strong nuclear force. Therefore, option C is the correct answer. Good. Let's see question number 11. The binding energy of a nucleus is the energy that must be supplied to A, remove a nucleus, B, remove an alpha particle, C, remove a beta particle, D, separate the nucleus into its continent nucleus. Which one is the correct answer for binding energy?
B.
B.
D.
D. Excellent. So binding energy is the energy required to separate the nucleus into its parent nucleus or parent nucleus. Very good. And let's see question number 12. If a nucleus has mass m and z proton, z is the number of proton, and for the mass of the proton is mp, and n is the neutrons, and mass of the neutron is mn. Its binding energy is equal to binding energy. Which option is correct? Option A, mass of the nucleus times speed of light c square. B, mass of the nucleus minus mass of the neutron d times mp minus mass of the neutron n times n is the number of neutron times mass of the neutron times the whole c square. C, mass of the proton plus mass of the neutron minus mass of the nucleus times c square. D, mass of the proton plus mass of the neutron times c square. Which one is the correct answer? From the
D.
last week's slide, the defect mass, which is given by the summation of the mass of the nucleon minus mass of the nucleus times c square. Therefore, for the nucleon here, mass of the neutron plus mass of the neutron minus m. So which option is correct?
D.
C.
Yeah.
Very good. C is the correct option. Question number 13. The greatest binding energy per nucleon occurs for nuclides with mass near that of A, helium, B, sodium, C, iron, D, mercury. Just check your textbook. There is a plot for the binding energy per nucleon. The greatest binding energy is around what?
Iron.
Iron, very good. Therefore, the greatest binding energy per nucleon is around iron. Have you seen from the plot of your textbook?
Yes.
Very good. Try to keep in your mind this. Maybe this will be one of your entrance exam. Okay. Now let's see question number 14. The half-life of radioactive substance is half the time it takes for the entire substance to decay. B, the time for radium to change into lead. C, calculated from M energy equal to mc square. D, the time for half the substance to decay. Which one is the correct option?
D.
D is the correct option. The time for half-life, the substance to decay. Very good. And let's see question number 15. The relationship between the disintegration constant lambda and the half-life T, for this case, we have seen last time T half. For this question, let's say the half-life is T of a radioactive substance is A lambda is equal to 2T, B lambda is 1 over T, C lambda is 2 over period, D lambda times T, the period equal to ln 2. Which one is the correct option?
D.
D. The half-life is given by ln 2 divided by the disintegration constant, which is the same as 0.693 divided by the disintegration constant lambda. Therefore, option D is the correct answer. What about question number 16. The half-life of radioactive isotope is 140 days. This is the half-life. In how many days does the decay rates of the sample of this isotope decreases to 1/4 of its initial decay rate? You will
280
use.
days.
Okay, very good. 280 days. How did you get it?
Because after the first half-life,
Mm-hmm.
50% will be remaining. The
Okay.
second half-life, 25% will be remaining.
Mm-hmm.
So the first and the second, 2 times the half-life
Okay.
will be 280.
Very good. The correct answer is 280. Okay, let's see. Let's submit our work. And let's see our result. So your response has been recorded. View your score. Oh, good. We got 16 up to 60. You can clap for yourself. Okay. This is all about Unit 8 about atomic physics. If you have any question, let me know.
Okay.
No question.
No.
Okay, good. So let's proceed to grade 11, chapter 6, or let's continue next time.
Chapter 6, we have half an hour.
We have half an hour, yes, 30 minutes. So let's continue grade 11, chapter 6.
Yes.
Okay, good. Okay, let's open. I don't have the PowerPoint for grade 11 part, so we will discuss from the textbook, okay? You can prepare your textbook for yourself and we can discuss from the slides. I will share it now. Textbook. Okay. Okay. Let's share you the slide.